This is Mr. Grice for Algebra Unit 8.3 Notes. Today we're going to be talking about identifying solutions of a quadratic equation from a graph. Our learning target today is to be able to identify the solutions and other important information of a quadratic from a graph. Woo! That's a mouthful. Well, are you guys ready to get started? Good. So am I. So the first thing that we need to know is what is a solution or solutions of a quadratic equation? Well, what that is the x-intercept, okay, or intercepts of the parabola. Okay, and it's written as x equals a number, okay? And those are our solutions, okay? So what it is the x-intercepts of the parabola, and it's always written as x equals a number, and we call those our solutions, okay? So if we had two real solutions, what that means is that there are 2 points where your parabola touches the y-axis, or the x-axis, I'm sorry. All right, so there you go. There's an example of 2 solutions. Okay? Well, one solution, okay? Well, your parabola touches the graph once, and that would be the vertex. Okay? And then no solutions, or no x-intercepts would be, there's my vertex, and it were to open down. So it has no chance it comes up and crosses the x-axis. Okay? So let's take a look. Given the parabola that fits the graph, blah, 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 the parabola that fits the description if possible. Okay, so here we are, we're going to graph. So I have to make sure that it opens up, its vertex is -2, -1, and it has 2 solutions. Okay, so here we go. Vertex, that's where we need to start, -2, -1. Okay, it's going up, and it needs to have 2 solutions. So there we go. Does it meet the criteria? Well, yeah, there's 1, there's 2. There's my 2 solutions. All right, let's look at the next one. Next one opens down. The vertex is at 3, 2, and it has 1 solution. So if I go to 3, 2, my graph has to go down and only has 1 solution. So I can go like that. Does that mean 1 solution because it only crosses once? No, because this other point, you drew an arrow, guys. So the arrow means it keeps on going. So guess what? This is not possible. Okay, there's no way you can do that. All right, let's look at the next one. So it says my vertex is at -1, -2. It opens down and has no real solution. So there we go, it opens down. Now, no real solution means that it does not cross the x-axis. And did it cross the x-axis here? No. So there we go, that's our graph. All right. So what we have to do here is identify the specified parts of the parabola. So let's go ahead and do this. The first thing is the vertex. Remember, the vertex is either the highest or the lowest point. And so in this case, it is the lowest. And that point is at 1, 2. So it's at 2. And then how many down? 1, 2, 3, 4. So 2, and that's a -4. So remember the axis of symmetry is the line, imaginary line, that goes through the vertex. And that'll be at x equals 2. Okay, the y-intercept is where it crosses the y-axis, which is right there. And that's at the point, what? Yeah, that's it, 0, 0. So the solutions now, so the solutions we would write as x equals, okay? I know there are two solutions because it crosses the graph twice. And so I would say that x equals, my first solution right here is x equals 0. And then x equals 1, 2, 3, 4. And then if I wanted those as points, it would be 0, 0, and 4, 0. Okay, so the solutions and the intercepts are the same thing. It's just a different way of saying them. Okay? All right, let's look at number 5. Vertex. Oh, that's weird. Right? Where is it? Well, I would say that that's at 1.5 comma 4. Okay? Now, remember our axis of symmetry goes through the x value. So that equation would be x equals 1.5. All right, now let's look. Y-intercept. There it is. And what is that value? Yeah, that's the point 0, 2. Okay, now I need my solutions. So I'm going across the x-axis and finding where it crosses. Okay? And so we would say that x equals, my first point is about negative 0.5. And then my other value is, let's see, it's 1, 2, 3, I'd say 3.5. Okay? And then writing those as points, it would be negative 0.5 comma 0 and 3.5 comma 0. Okay. Number 6. Why don't you guys try number 6, do as much as you can, pause the video, and then we'll do the rest together. Okay, so our vertex was at negative 3, 0. Our axis of symmetry is x equals negative 3. What'd you put for y-intercept? Do you see a point where it crosses the y-axis? I don't. So what I would write is can't be seen. Okay. And then my solution is x equals negative 3, and our intercept is negative 3, 0. Okay. That's an example of one solution. Okay, let's go ahead and flip it over. We're going to go ahead and pause this real quick. Okay, so during baseball practice, we're working on the word problems now. During baseball practice, Mario threw the baseball to his friend, but he didn't catch it and it fell on the ground. The graph below shows the path of the baseball. Let x represent the time that passed after he released the ball in seconds, and y represent the height in feet of the baseball from the ground. So, in terms of the context of the problem, what is the vertex and what does it represent? Okay, so first thing we have to do is we have to find the vertex. Okay, so where's the vertex? Do you see it? Well, remember, the vertex is the highest point of the graph. So I'd say it's right around there. Okay, now, what number is that? Ugh. Well, look to see what they're counting by. We said 0.1, so this is going to be 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, okay. So I think I'm a little off on that. I'd say the highest that it gets is right there. And that's close, so we're going to say that that is close to 0.4, but then on the right-hand side, we're counting by 2's. So we have to pay attention to the graph. So the height of it was at 10. Okay, so, but what does that mean? Well, you're throwing a baseball, right? Okay, so what that means is as I'm throwing this baseball, or Mario, whoever threw it, that's as high as the ball gets, because after that, the ball starts to what? Yeah, it starts to drop, okay? So, what does it represent? It is the maximum height of the ball, which we said was 10 feet, after 0.4, after 0.4 seconds from its release. Yes, we are making you right in this. Deal with it. Okay. So what is the y-intercept and what does it represent? Okay. So the y-intercept, remember that's where it crosses the y-axis. And that's about 0, 5 because it's in between the 4 and the 6, right in the middle there. Okay, so what's that represent? Sorry, we're estimating. Forgot to put the squigglies. Well, it's the height, right? Okay, so what it is it's the height of the ball before Mario released it. So it's the height of the ball before Mario released it. So estimate how long it took for the baseball to hit the ground once Mario threw it. Okay, so this is where I'm kind of counting. That's 0.8, that's 0.9, and this is not 10. It would be 1. So as we're looking at it, where's the ball when we're done? Okay, I'd say we're about right there. And that's when the ball hit the ground. So we would say it took, what number do you think that is? About, because we're not sure, I think it's about 0.95. It's right in between the 0.9 and that would be 1. So 0.95 sounds about right. It takes 0.95 seconds. Okay? So we're looking at the graph and then figuring out all this information. All right. Next one. So the graph below shows the height of the water stream from a drinking fountain. Let X represent the time passed since pressing the button to turn the fountain on in seconds, and let Y represent the height the water stream from the basin in inches. So what is the vertex and what does it represent? Okay, so once again, I'm just going to go through and kind of label this 0.1, that's 2, 3, this is 4, this is 0.5, 0.6, 0.7, 0.8, 0.9, and that's going to be 1. That's going to be 1, this one's going to be 2, that's going to be 3, and that's going to be 4. Okay, so I like to go through and label everything. So what's the vertex and what does it represent? So let's take a look. Here is the exact height, right? Is that as high as it gets? Maybe it's just a little bit over. Sorry guys, I'm trying to look as close as I can to this thing. Yeah, I'd say right about there. Okay, so if this is 0.4, we're in between 0.4 and 0.5. So that would be a height, we're kind of, or oh my gosh, Mr. Grice is having trouble right here. So it's 0.45 seconds, and the height of that, this would be 4.5. So what does that represent? Yeah, it's the maximum height of the water in inches after the amount of seconds. So it is the maximum height of the water and we said that that was 4.5 inches. And it's after, so 0.45 seconds after being turned on. Okay, so don't pay attention to that part. That looks like it's just the reflection. That's what was confusing me. Okay, so what is the Y-intercept and what does it represent? So where's the Y-intercept? Yeah, it's about right there. So we got to say that the Y-intercept is about 0 and it's 1.5. So there's my Y-intercept. What does it represent? Yeah, that's the starting height. So it is the starting height of the water. And if you want to say 1.5 inches, that's completely fine. Okay, so what was the height of the water stream after 0.3 seconds? So remember that the time is down here, so 0.3, we're just going to look up, we're going to look up, we're going to look up, and it's right about there. So what height is that? Yeah, it's about 3.5. So I would say about 3.5, not seconds, guys, inches, because it says what is the height? And then when was the height of the water stream approximately 2.5 inches? Okay, so first we looked at the height, or the time, now let's look at the inches. So I'm at 2.5. There's 2.5. How many times does it hit? Yeah, it hits twice. It hits right about here, and then again, right around there. So we have to write both of those times down, okay? So I would say at the first one was about, it's in between 0.1 and 0.2. So at 0.15 seconds, and the other one's right about there, and that's right about 0.8. Okay, and that makes sense because it's going to go up, it's going to hit, and then it's going to go down and it's going to hit again. Okay? All right, that was it for that problem. Now let's move on to question 9. So it says the equation of the arch on the bridge below is y equals negative 0.00116 parentheses x minus 251.5 parentheses squared plus 73, where x represents the horizontal distance of the arch in feet and y represents the vertical height of the arch in feet. What is the vertex and what does it represent? Now, don't freak out. Be like, I have no idea. It's in vertex form, guys. Okay, so look at our equation. We know that we have to take the opposite and this number stays the same. So our vertex, this was negative 251.5, so it's going to be a positive 251.5. And then the other number stays the same, so comma 73. That's the vertex. So at my vertex, which would probably be about right there, what does that represent? It's the maximum height, okay? So the max height, this is the max height of the arch. So the max height of the arch, which was 73 feet, and then it's going to be at a horizontal distance of 251.5 feet. Oh, sorry, we don't need that parentheses there. Okay. So the reason why I got that, okay, I know that's 73. We talked about that the y is the height, okay, y is the vertical height, and x is the horizontal distance. So I'm just getting that directly from the problem, okay? Now, what is the vertical height of the arch if the horizontal distance is 140 feet? So they're telling me the horizontal distance. So they're telling me the x. So I know the equation y equals the negative 0.00116. I'm plugging in 140. I need to find out what this number is, and how are we going to do that? Well, yeah, we could plug the equation in and then look in the y-axis trying to find it. I think that's a lot of work, okay? So what I recommend, hold on. Okay, here we go. So I'm just going to plug it in, the negative 0.00116 times 140 minus 251.5. Remember, that is squared plus 73, okay? And when you enter that, you're going to get this big number. We can round it to the first decimal, and that's about 58.6. So it's about 58.6 feet, okay? So wherever 56 feet is, I'm just going to guesstimate, like, oh, maybe it's right here. That's the height, okay? I'm not sure if that's the exact spot or not. I was just guesstimating, okay? So I know some of these word problems can be tough. If you have questions, please come see Miss Carranza or myself. That's what we're here for, okay? Otherwise, this is Mr. Grice signing off for Algebra 3, Algebra Unit 8.3 notes. Thanks for watching.